Are we working?
Yeah.
Okay. Now, let's just review. I kind of checked off that video. There was a lot of squeaking, a lot of chairs moving, a lot of weird things going on. So you guys know what's going on. So let me explain what I did here. Understood? Okay. We have 3 scales. This scale is 20 to 30. Yes? 10 gradations. This is 2,000 to 3,000, 200,000 to 300,000. I have the same position on each scale, correct? The first thing I do is do the precision, which is 0.1 here, correct? So I know that's 0.1 because this is tens, ones, tenths. Tens, ones, tenths. Thousands, thousands, hundreds, tens. Thousands, hundreds, tens. 100,000. Now I say 1,000, is that right? 100,000, 10,000, 1,000. That's correct. It's always 2 less than the largest gradation, place value, or 1 less than the smallest gradation. Are we okay? We're going to read this across, okay? No, we read this one across first, right? So this is 23.5. The 5 is the estimation, tenth. This one is going to be 2,350. That 0 is not read from the scale because in tens, 5 is the lowest place. That's read from the scale. 2,350. 2,350. 50 is the 5 is the estimation. Here I have 200,000, 200,000, 100, 200,000, 200, 200,000, 300, 200,000, 300.
235,000.
235,000, sorry. So get it? So 200, what did I say, 210,000, 220, 235. Get it? Okay, good. Now, these zeros are not within the precision, so they're not read from the instrument. 25.0, 2,500, that 0 is within the precision, it's read from the scale. That's where we are. I'm going to say this. If there is a digit, there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? Those are digits, correct? Numerals. They're not numbers, they're numerals, they're digits. We have 10 digits that we can use. These are digits. 2 is a digit. 5 is a digit. 0 is a digit. 0 is a digit. They're digits, correct? If there's a 0 digit, that's not read from the scale, it's not significant. If it is read from the scale, that 0, it's significant. It's a significant digit. We call them significant digits. How do you spell digit?
D-I-G-I-T.
Okay, I want to put a D in there. Or significant figures. If those are a significant figure, something you read from an instrument. So are these significant here? No, because I didn't read them from the instrument. You see that? What's this one going to be? Well, it's going to be 250,000. Is that significant? Yes, because it's in thousands place. So that's significant. Clear? Easy? Yes?
So what's the definition of significance?
A significant figure is any figure, any digit, that comes from the scale on an instrument. Clear?
Yes.
Are you sure? Okay. So that's it. Now keep it rolling. Where's here it is. Keep it rolling. Don't move me. Don't move. All right. So now what I'm going to do is I'm going to write these 6 as scientific notation. Now You don't have to write this down because I'm gonna tell you. Scientific notation, you gotta remember three things. First, scientific notation only uses significant digits. That's all it uses. Doesn't use insignificant ones, only uses significant ones. Two, there's only one significant digit to the left of the decimal. That's it. Obvious? Okay. Then you correct for magnitude by using base 10. Clear? Okay. So, this is gonna be, we'll do this one first. 2.50 times 10 to the 1. You use, these are all significant. These are significant. 1 to the left of the decimal, so you're putting it here. So you have to give 2.50, thank you, Sydney. You put 2.50, you gotta give it a magnitude of 25, right? So you gotta multiply it by 10 to the 1. 10 to the 1 is just 10, right? So 2.5 times 10 is 25, correct? So that's correct. This one, 2.35 times 10 to the 1. Clear? Are you okay with that?
Yeah.
Okay, let's do this one. We'll do this one first. 2.50 times 10 to the
Second, third part.
third. Yeah, because you gotta multiply, 10 to the third is 1,000, right? So you gotta give this a magnitude of 1,000. So you use only significant digits, right? Get it? Next one, 2.350
Times.
oh, times, okay.
To the third part.
Get it? All right, you do this for me. Somebody. Yes, do this one for me. 2, what do I write? That's right, 2.50, very good, excellent. Times 10 to the 5, perfect. 1, 2, 3, 4, 5. 5, excellent, well done. Well done. Okay, and what about this one? You want to give that one a try too? Oh, you're very brave, excellent. So 2.35, is that what you said?
Yeah.
Excellent, times 10 to the 1, 2, 3, 4, 5. 5, you guys are good, I'm telling you. Okay, excellent. So that's scientific notation. Now, let me do one more thing. I still have 2 minutes, and I'm going to completely blow your minds. Okay? Are you ready? All right, and then we're done. Okay? Give me like 3 minutes, okay? Okay. Now, let's talk about. Right. All right, give me a minute, guys. Let's talk quickly about reducing data, some rules. For instance, what is 2.0 times what is 2 times 10.0? What does that equal? What does that equal? What is 2.0 times 10.0?
20.0.
The rule is this. Listen carefully. Listen carefully. The rule is this. When multiplying or dividing, your answer must have the same number of significant figures as the measurement with the fewer number. This has 2, this has 3, 2 is fewer than 3, I must have 2. So if I say 30.0 divided by, what, you want me to really go crazy here? Divided by 2, what's the answer? 15, nope. 20. You can only have one significant figure because you have one here, you have 3 here, and you have 1 here. So I can only have one significant figure in my answer. So you got to round out to 20. Weird, huh? I know. I know there's special rules with 5 doing the rounding, but we're going to ignore those statistical rules. Don't worry about it. So what happens if I have 40.0 divided by 20. What's my answer? No. 2.0.
Why?
All right, give me one more, can you give me one more minute?
Yes.
Is that okay?
Yes.
Okay, so 2, 3 here, 2 here, 2. 3 here, 1 here, 1. 2 here, 3 here, 2. You get it so far? All right, give me one more minute, okay? Just one more minute. Okay, now what happens if I do addition and subtraction? This is what's really going to blow your mind. You ready? Let's say I have 400 plus 35.0.
Wait, what?
435.
There's no decimal point there.
435.
All right, so what you do is, you do it mathematically, do the math.
440.
Okay, now, correct it. Now listen to the rule. This is the rule. You ready? Write this down at home. At home, don't worry about it. Okay. When adding or subtracting, your answer must have the same precision as the measurement with the worst precision. When adding and subtracting, your answer must have the exact same precision as the measurement with the worst precision. What's the precision of that measurement?
10. No, 1.
100, right? Right? Right?
Oh, yeah.
Okay. This precision is tens, right? Which worse? Which is worse, 100 or 0.1?
10.
That's worse. It's terrible.
Why?
The farther you go to the right, the better the precision. The closeness, remember, precision is closeness. So this is a better precision than this. This is a terrible precision. So what must it be rounded to? My answer has to have a precision of that.
500.
No, 3 doesn't round 4 to 5. Come on, girl.
400.
That's it. You get it? Do one more and then you're gone. Okay, watch this. So let's do this. Let's say this plus 95.0. So you do the math. Do the math. 495.0.
500.
No. No. Oh yeah. Okay. But what? So you want to round this to what?
500.
You got to have, this has plus or minus 10, this is plus or minus 0.1, so it's got to have tens place, so you're going to do this to round that, which is going to round that. It'll be 500, but is that, how do you write that?
0.
No, if you write a point, then that answer has a precision of plus or minus 1. But it doesn't. You have to have plus or minus 10.
Ah.
We're done.